All right, verifying that something's a subspace. So it says verify that the set of points of this form is a subspace of R3. So really, this is no different than just verifying that it's a vector space, except for we have to just notice, yeah, this is in R3. So let's do this. First, we'll check vector addition. Whoops, where'd it go? Here it goes. So first, we'll do vector addition. So we'll pick two arbitrary vectors of this form. A, B, and this next one is going to be 3 times the first minus 2 times the second. And now I'm going to pick a second one. And wait, that shouldn't be a y there. That should be a 2b. Now I could pick a second one by using a different variable, or I could decide to just subscript these things. So that's a1, b1, a1, b1, a2, b2. And then this will be 3 times the first minus 2 times the second. So if I do this and add these guys up, I get a1 plus a2, b1 plus b2, and then over here I get 3a1 minus 2b1 plus 3a2 minus 2b2. That sure is long. I'm going to recopy it. And let's see, I can rearrange this into 3 times a1 plus a2. And then minus 2 times b1 plus b2. So this does have the correct form. What we've got here is 3 times the first minus 2 times the second. So this is closed. Now we have to do a similar thing with scalar multiplication. I'm going to make this bigger so I can fit it in here. Scalar multiplication. All right, so I'm going to take an arbitrary vector, or point, whichever you want to call it. So a, b, and then this is 3 times the first minus 2 times the second. And I'm going to multiply it by an arbitrary constant, c. When I do that, I get CA, CB, and 3AC minus 2BC. And I have to look at this and say, is this 3 times the first plus, minus 2 times the second? Yeah. So therefore, this is closed. So that's what I have to show in order to show that this is a subspace of R3. All right, let's look at one more. Verify that the set of polynomials of this form is a subset of P2. Now remember, P2 is the set of polynomials with degree at most 2. And this is saying, you know, these are just certain polynomials, things like 3x squared plus 5. Basically stuff with a 0 for the coefficient of x. So for vector addition, we're going to take 2 of these, a1x squared plus c1, and then a2x squared plus c2. We're going to add these together. We'll get a1x squared plus a2x squared plus c1 plus c2. And does that have the right form? And maybe it's kind of tricky to see. What is it asking for? It's asking the only things that the A's and the C's and stuff up here specify. I mean, A and C can be anything, but the important thing is the T, or the X coefficient is 0. And is the X coefficient 0 in here 0? Yes. So this is closed. Maybe I should say because X coefficient is 0. Now let's do scalar multiplication. If I take an arbitrary thing of this type, Now they've got a c there, so I'm going to use k for my constant, or for my coefficient. If I distribute that across there, I get ka1 x squared plus kc1. And again, my x coefficient is 0, so therefore it's closed. So it's closed under addition and scalar multiplication, so therefore, yes, it's a vector space. All right, one more of these. Verify that this set that is a subspace of M23. Remember, that's a set of 2x3 matrices. So what I'll do is basically the same thing we've been doing. For vector addition, that's a plus. Let me write it a little better. So for vector addition, I'll take two of these things, A1, B1, D1, A plus B, 4D, 0. Basically, I'm just taking that and I'm subscripting it with 1s. I'm going to add another one on, but I'm going to subscript it with 2s. Let's see. So when I add those together, let's see, this is going to be A1 plus A2, B1 plus B2, D1 plus D2. Let's see, this entry here is going to be A1 plus A2 plus B1 plus B2. The next entry is going to be 4, I'm going to go ahead and write it as D1 plus D2. And the last entry is 0. So what we've got to check here is, well, let's see, what is it that makes this special? This has to be 4 times that. And is that true here? Yeah. Maybe I should do that permanently. This has to be 4 times that, and we're good. And also, this is supposed to be the sum of these two guys. And this is the sum of these two guys, so we're good. So it has the correct form, therefore it's closed under vector addition. And then for scalar multiplication, if we take that and multiply it by c, and really when you're doing scalar multiplication, you don't have to put the subscripts on there because you've only got one of these. So I'm going to multiply that out to get CA, CB, CD. This is going to be CA plus CB. This is going to be 4CB, or I'm sorry, 4CD, and then 0. So again, we're checking, is this 4 times that? Yeah. Is this the sum of these two? Yeah. Therefore, it's closed. It's closed under scalar multiplication, and therefore it is a vector space.